All right, this is probably going to be a terrible demonstration, but I wanted to try to kind of explain the problem that Foerster is going to have you look at. Foerster is going to have us look at the idea of a rate of change by looking at a swinging door, okay? And you've probably, back in the days when you could go in a store, you've probably gone to stores that had accessible doors where you can hit a button and the door will open automatically, and the door will kind of spring open, and then the door kind of slowly eases shut because you don't want little kids going through the door and getting crushed in the door. Or you might have opened a screen door. I know my grandmother lives in an old like farmhouse type house, and it's got this old wooden screen door with a spring on it, and you'd kind of push it open and it would go, and then the spring actually would pull it back pretty quick. It would kind of snap shut afterwards. So you might have seen some doors with some kind of a door opener. So that's the scenario that Foerster's having us look at in section 1.1. And I want you to kind of visualize what's happening here. This is not exactly the scenario that he describes, but it's reasonably close. So what I want you to think about, we're going to be looking at the rate of change of the door as it opens. We're going to be looking at the rate of change of the door's openness in degrees as time goes on, okay? So I want you to think about how many degrees the door is open currently, and how many degrees it will open totally through this time period. We're going to try to put together a graph showing degrees that the door is open, degrees of openness on the y-axis, and time on the x-axis. So I'd like you to kind of try to be envisioning in your head what that graph might kind of look like. This is not exactly the same as Foerster's scenario, but it's not too far. So what I'm going to do here is I'm going to fling this door open, okay? It's going to hit the door stopper here, and then it's going to close. And again, I want you to think about it. If you had degrees that the door is open on the y-axis and time on the x-axis, what would that graph look like? Okay, so here's the unbelievably brilliant demonstration. Door is shut, 0 degrees right now. I'm going to fling it open. It's going to hit the wall, and then the door is going to slowly shut, okay? It should have shut, but anyway, more or less shuts, okay? So I want you to think about what that graph would look like. Degrees on the y-axis, time on the x-axis, okay? I'm going to try it one more time. So I'm going to fling the door open, and then the door is going to shut, okay? That's the kind of thing that we're trying to model, okay? So I'll come back in a second on the video, and we'll take a look at what the graph of that might look like.